Hello and welcome to lesson number 6 in Unit 1, Linear Systems in our Grade 10 Academic Math class. This is Solving Linear Systems, Substitution versus Elimination. So we've already learned our two algebraic methods for solving linear systems. Now this lesson is sort of a way of practicing them, but also a way of determining, when you're looking at a linear system, what is the most effective or efficient way to go about solving it. Is it going to be substitution or elimination? So we're going to look at a few examples. Let's start with the first one here. First one, x plus 3y equals 2, 2x plus 5y equals 3. What is going to be the best way to do it? Again, you can pause here and copy it down so that you can just listen while I talk through it, or you can copy while I talk. Either way is fine with me. I would choose substitution for this particular one, and I'll show you why. You'll see in equation number 1, we've already got a nice isolated variable. We've got a singular x. If we rearrange number 1 to turn it into number 3, like equation number 3. It just requires one step, substitutions in there, and then we can proceed. It's pretty straightforward. Hopefully the procedure now is fairly familiar, but just again talk you through it. We start by rearranging 1 to isolate x, so we have x is equal to, so this is a known amount of y that is equal to x from our first equation, negative 3y plus 2. Then I'm going to substitute the rearranged number 1 into number 2, which I've done in this step here. So instead of 2y, I sub in an equivalent value for y, minus 3, or sorry, instead of subbing in an x rather, I substitute in an equivalent value for y, negative 3y plus 2. I expand out and I simplify and I isolate my variable, and I end up with y equals to 1. From there, I substitute back into either one of them, but I chose number 1 here. We're substituting y equals 1 into equation number 1, and when we evaluate for x, we get a solution of negative 1. So our solution is negative 1 and 1. Hopefully that makes sense. Again, this is going to be substitution. Let's look at our second equation now. We have 6x plus 5y equals 22, negative 4x plus 3y equals 36. This one should be elimination for sure. The reason being that if I were to try to isolate any of my variables, say y's or x's, in any of the equations, I'm going to end up with fractions. Meaning that, like, let's say for example, I wanted to bring 4x to the other, bring 4x over to the other side. I'd be adding 4x, and then I'd be dividing by 3. So I would have 4/3 x plus 12, and that's not great. So in an effort to stay away from fractions, in a question like this, it's already nicely lined up as well. I'm going to recommend elimination. We do, however, have to ensure that at least one set of variables has the same coefficient in front. In order to do that, we're going to have to multiply both equations in this case. I'm going to shoot for the variable x, and I have 6 and I have 4. Both of those are multiples of 12. So if I'm going to shoot for 12, I'm going to want to multiply the first equation by 2, and if I want to get to 12 in front of my x in the second equation, I want to multiply by 3. So I'm going to do that now. We are going to then end up with a new number 1, and that's going to be 12x's. I'm just multiplying each of these terms by 2, plus 10y equals 44. That's my number 3. And I'm going to multiply every term in the second equation by 3. So that's going to give us negative 12x plus 9y equals 108. And that's my equation number 4. Okay, so you can see I've got my two 12s there. Procedurally, are we going to add or subtract this? Well, because the 12s have two different signs, we are going to be adding them. Because a plus 12 adding a negative 12 gives us 0, so that's going to be 0 x's. We have 10 plus 9, that's going to give us 19y, and we're going to add this, so that's going to be 152, and man, I don't know if that's divisible by 19. I might need the calculator for that one. So we've got 152 divided by 19, that's going to give us 8. That's awesome. It came out nicely. So we've got y equals 8, and that is our the first component of our solution. Now we are going to, as with substitution or elimination, we are going to sub y equals 8 into one of our two original equations. I'm going to pick the easiest looking one, which looks like, actually they both look about the same. Let's just pick number 2, just because. So we're going to sub that into 2. We have negative 4x plus 3 times 8 equals 36, I think it is. Yep. And now to do some evaluating. 3/8 are 24. There's our 36. We are going to isolate our variable term by transposing 24 to the other side, by subtracting 24 from both sides. That's going to give us negative 4x equal to 12. And now to isolate x, we divide both sides by the coefficient out front, which is negative 4. X then equals negative 3. And now we pop a little therefore statement on there. So therefore, again, we're going to forsake checks here, or forego checks, just in the spirit of keeping the video moving along. Obviously, checking is always a really good idea. It's nice when you have questions like this where, because you can do a check, you'll know whether or not you got your answer right. So therefore, the solution is, let's see, that's going to be negative 3, 8. Negative 3, 8. There's our therefore statement. And there we go. That is, I think, a pretty straightforward choice for elimination. We've got a couple more examples here. Maybe we'll just cut this video directly up in the middle here, and I'll just do these last two in the second part of this video. So there's part one. Part two is just a couple more examples, and then you can get down to practicing the most efficient or effective way of solving linear systems, whether it's substitution or elimination. We'll see you in part two.